So, let's get right to it. Today, I'm going to be discussing layered governance for your infrastructure. This talk is going to mostly be about different tools, workflows, and methodologies that you can use and apply to your different pipelines, whether you're using GitHub Actions or Jenkins, GitLab CI, just anything that you're using, you can apply all these ideas to those various workflows that you have. My name is Taylor Dolezal. I am a developer advocate at HashiCorp, and I work mostly on the infrastructure team. So that's setting up infrastructure with Terraform, potentially tying in some automation with console and firewalls and network policies, and then application delivery as well. So I'll work with Nomad and Waypoint and Vault, Packer, all of our different tool suite to facilitate different application workflows. Now, you can find me just about anywhere online as @onlydole. I really enjoy reading, so if you have any wonderful books that I can add to my Goodreads reading goal for the year, I'd very much appreciate it. I also work within the Kubernetes space as well, work with the community there, mostly in SIG release, which is special interest group release, focused on Kubernetes releases, and the SIG docs group as well. So that's the Kubernetes IO domain and the documentation that's hosted upon it. If you have any questions, you want to reach out and ask me on that front, how to get involved, fun Kubernetes questions, I'd be more than happy to answer on that front. So please, at me. So let's get into it. So today, we're going to be talking about many things. First off, we're going to be discussing GitOps. What is it? How do we use it? What are some of the tools that we can use for that? On that front, we can use Flux, Argo, Jenkins X. There are a lot of tools in this space, and today we're mostly going to focus on, well, really just only focus on Flux and ways that we can use Terraform to stand up Flux in your Kubernetes clusters. Next, we're going to discuss policy as code. For that, we're going to use the Open Policy Agent project, and inside of that project, we're going to be using the Gatekeeper implementation of Open Policy Agent in our Kubernetes cluster. And you keep hearing me say Kubernetes, and that's because that's mainly the context that I'm going to focus on today. But know that you can use all of these methodologies in just about any kind of context that applies to your workflow. So don't fret, even if this doesn't match your environment or your workflow exactly, you can still apply it to that. Lastly, we're going to end up with a live demo. I'm going to go through and show you how you can use Terraform and stand up Flux within a Kubernetes cluster. I'm going to be using Kind, the Kubernetes and Docker project, to make a local cluster and then apply that configuration to that cluster. Then after that, I'm going to show you how we can stand up Gatekeeper using a Helm chart in Terraform, and how we can actually validate some namespaces in that demo. It's going to be fun. So, kicking things off, let's talk a little bit about GitOps. So like I had mentioned before, we're going to be using the Flux project to illustrate a lot of the ideas in today's session. So what is GitOps? GitOps is a framework that allows you to immediately make use of the best DevOps practices. It's kind of a batteries included framework, and it's quite helpful. The reason it's helpful is because it enables collaboration. No longer do you have someone configuring a cluster or setting things manually, running kube control apply on config maps, deployments, services. This allows for teams to work together. Granted, they know how to kind of read the manifests and work with Flux as a tool or Terraform. You're able to kind of open up pull requests and then work with a same common language. This also helps you access or govern your access control, mostly because it's Git repositories, whether that be GitHub, GitLab. you can assign various access to those repositories and then know who's actually going to be the one deploying or working with those repositories. It's really helpful. Next, it's less risk and less error prone. And that's because you have the ability to create these files and then pull request them, get reviews on them, and again, work as a team to see if that's really, the best setup for what you want to add to your cluster. Flux allows Flux will kind of stand in as an intermediary as you add these files, and then it will get them spun up for you, so you no longer have to do those manual applies or anything like that, and that generates a really fast feedback loop. Do you deploy something out, v1, there might be an issue with that, and you can quickly deploy your 1.0.1. So when we talk about GitOps and we talk about Flux and Terraform and all of these different tools, really in technology, we have a tendency to talk a lot about the tools themselves and get away from focusing on the different workflows that we have to support. And I thought this picture really illustrated that. You can have things that are within the same environment, but they can be different and they can complement one another. You can find the right boundaries to set between what each of these tools is supposed to do. Now, I'm quite guilty of picking up a tool and trying to find, how I can apply that everywhere. But that's just not the best practice, right? So when it comes to Terraform and it comes to Flux and it comes to all these other tools, we really need to be cognizant of where we're actually applying them. So with this, Terraform is really great at standing up all of this infrastructure. Flux and GitOps are really great at operating in the space in which you've already set things up and you want to continuously integrate and deploy to them. So just one thing to make note of, and then also this person on the beach. That's they've picked a wonderful place to be. So that's GitOps. Let's talk a little bit about Flux. How do you actually go about using Flux? So first off, I will share out slides and code, but know that the first thing with Flux, you have to bootstrap it. You can either use the CLI tool to install all of the dependencies, or you can use Terraform like I'm going to show you how to do in the live demo. Flux does manage itself and set itself up once you have kicked off that process. It's fairly easy to install. Next core concept of Flux are sources. What sources are sources. What these are just areas that you have your code in. So whether that be a Git repository, a Helm chart, just Helm repository, or something like a storage bucket within your favorite major cloud, you can use all of those as sources for Flux to kind of keep an eye on and see what state each of those sets of code is in. If I change from v1 to v2, this is where Flux is going to keep an eye on that. It's going to take a look at those commits and such. One of the next core concepts of Flux is customization. So what customization is really an abstraction layer on top of your sources. These are typically used with Git repositories, and you don't have to really leverage them. You do have to instantiate them within your Flux deployment, as you'll see here in a bit, but you don't have to transform things. This just gives you the ability to, if you want to potentially treat your deployments in a Kubernetes 119 cluster different from a 120 cluster, or if certain conditions are met and you need to do some different things, customizations help. They allow you to templatize out the different behaviors that you might want with your Kubernetes objects. Next is reconciliation. What reconciliation is mostly that Flux is going to go about changing everything within the cluster to meet exactly what you have declared within your Git repository. So pretty straightforward. But if you have any questions on this step, please feel free to ask, or check out the Flux documentation. There's quite a bit there, and it's really helpful if you want to kind of understand the internals and what's going on within Flux. So, say we get everything installed. We're going to be running this command in our live demo. Say that we've gotten everything installed and we actually want to declare a source for Flux. This is how we would do that with a command line. And then this is the manifest that would be generated from running that command. I'll show you how that how this is used in just a little bit here in our live demo. Just make a mental note of the fact that you can set up a source this way, or you can just, if you have an understanding of how the manifest is laid out in the API there, you can just instantiate that directly. Same thing for the application itself. In the demo, we'll be deploying an application called pod info to our cluster, and really just contains information about the pods. We're just going to get that up and make sure that everything is running. And then this is actually deploying that application. We have the source. This is the customization that actually makes sure that we have our deployment object, our services, and everything that we need on that front. This is what that manifest would look like. All right. Next up is policy as code. So in these examples, I'm going to be using the Open Policy Agent, but again, know that we have a lot of tools in this space. At HashiCorp, we have Sentinel, which is not open source at this current time, and is really more of a set of features that enhances different enterprise offerings that we have, whether that be Vault, or Terraform, Nomad, Consul, or if you're using any of our cloud offerings. Open Policy Agent is nice because it operates within the open source space, which I'm a huge fan of, and OPA is not really tied into anything. Open Policy Agent runs as its own agent, or it exists within another abstraction, like Gatekeeper, which integrates directly with Kubernetes, or conf test if you want to write certain tests operating on JSON data. So as you can see here, this is really just how OPA works, just a simplified view of how everything is stitched together here. When you're writing policy in OPA, you're using the Rego language. It's not Prego, it's not pasta sauce. Very close, but quite different. Policy tastes very different. Not that I've ever had it before, but it's quite different here. So again, we'll be using Gatekeeper as the project of choice in our Kubernetes cluster, and it really acts as a gatekeeper. It either allows things in because that's what our policy permits, or shuts things out, closes the gate, doesn't allow it to happen, and authorizes things, and making it quite easy. Now, the Gatekeeper project has a library that has a lot of great policies that you could start with right out of the gate. That's where I've sourced one of my examples from. And really what we're going to be doing is setting up a namespace constraint such that you have to specify the owner that belongs to, and then it has to satisfy a little bit of regex on that front. So let's go ahead and get right to the live demo. Let me get set up here. All right. Any fans of VS Code in the crowd? Can't see your hands. So let's take a look at everything here. I think that might be a good size. Let me bump things up just a bit. Okay, I think that'll be a good size. So what we're going to be doing today is I've already stood up a kind cluster. So what that is kind is a fantastic community project. It allows you to spin up a local Kubernetes cluster. You can use Minikube, you can use Docker for Mac, Windows, Linux, but this is very easy, and I like the specificity that you get because in this, behind here, again, I'll share this code with you. You can see that I'm setting up a cluster. I've got my control plane here, and I'm able to specify right down to the commit what version of Kubernetes we're going to use. So I've got nothing up my sleeve here. Let's go ahead and run a kube control. I've aliased that to the letter K. Get nodes, which is just NO. So we can see we have really 4 machines here. Let's go ahead and get the namespaces. Kube control, get namespaces. Using a little bit of Kubernetes shorthand here, just because I'm a fan of typing less. So we can see here are all of our default namespaces. And if I were to go ahead and get all of those pods across all the namespaces, we can see it's let me close this. We can see that it's not really anything out of the norm, right? Okay. So we're looking good here. Let's go ahead and pop open our first set of things that we're going to want to take a look at. So I'll go ahead and minimize this shell for now. And you know what? I'm actually going to go ahead and minimize this as well. So again, I'll share this code with you, but this is the Flux provider. This is it. This is how we're going to install Flux on our Kubernetes cluster. Very easy to use. We just have to specify some variables. I'm going to keep them hidden for this demo, but you can poke through those in a bit at your leisure. This creates the manifests that we need for deploying Flux to our Kubernetes cluster. And then over here, we have some more for just reconciling that specified repository. So this actually links it together with a repository that we're going to create on the fly, actually. In here, in GitHub, we're also going to be using the GitHub provider because we need to create a GitHub repository that we store all of our cluster state and configuration. It's actually where we're going to go about adding in all of the different assets for that cluster. So we have GitHub repository. This is just defining the default branch. And then these 3 files here are just, these are going to source from the Flux provider. And what this does is, again, just bootstraps our GitHub repository with all of the files that we need just so that it works with our cluster and we can actually start to reconcile things. It won't deploy anything just yet. We're going to go ahead and add that. In this is probably one of the largest bits of code. This sources not only the Kubernetes provider, but the kube control provider as well. Now, HashiCorp has a Kubernetes Alpha provider, which is going to support CRDs and manifests, but a lot of the examples for Flux work mostly with this kube control provider, so I'm just going to stick with that. You could use Kubernetes Alpha, though that will be kind of rolled into the Kubernetes provider at some point in time, soon. We're going to be creating a Flux system namespace and then use some data sources to actually source what manifests we want to install. We're going to loop through that. One of the newer additions to the Terraform language is that the core language is that we can actually iterate through and use a for each, which we're doing here. And then really that's about it. We're installing github.com because we want, this is a known site. We just kind of want to install that at this point in time. The examples used locals. You could just use variables if you wanted to here. Locals are usually used for computed values. This one is static though, so it doesn't need to be a local, just to sync with the documentation and make it a little bit easier to follow along with. And then lastly, this is the Kubernetes secret. We're creating a deployment key that Flux is going to use. We're letting Terraform handle that state. And so because we allow Terraform to glue all of these things together, we can actually source all of these different names and that deployment key, which is really helpful because it's just no one wants to go in and manually add deployment keys or kind of make that a different step of the process. This will all get handled here. Lastly, we have, this is our Terraform TF. Typically, this can be named provider, Terraform, something of that nature. And what this is this allows me to set my required providers. It's very important to pin your dependencies. Otherwise, you can it makes things very painful if something updates and you're not expecting it to. You lose that certainty, and you lose the ability to have that declarative infrastructure and that repeatable type of pattern. So we can see in here, I've pinned all of these to their minor versions, and then down here I'm using the Terraform cloud to store my state. All right, so now that we have all of that, I'm going to pop open the shell. I'm going to go into the GitOps folder. So with each of these examples, you can drill down into the specific folders and then run this Terraform code. Note that I did have my backend set, so if you are working with this code, you'll have to go ahead and change that to whatever Terraform cloud workspace that you have and sign in, or you can just get rid of that and execute this example locally. So let's go ahead, Terraform lifecycle, let's just go ahead and run an init and make sure that everything is as we expect. I think everything will be fine here. GitHub has switched to integrations, or integration/GitHub, and is at 4.3, just as a heads up. But right now, that version of the Terraform provider supports organizations, doesn't support personal repositories, and so that won't work with us today. So we're going to see an error about that. We can see that right there, and our init ran successfully. Go ahead and clear this out. All right. So let's go ahead and do a Terraform plan and make sure that everything is as we expect to get stood up. This is actually going to be the step that installs Flux onto our local cluster. So I think we have about 30 plus, or 38. Oh my goodness. Quite a few things to install. So that looks correct to me. If you wanted to, you can scale up and kind of see what different manifests, what things are actually getting created. Yeah, that's about it. All right, so we've done a plan, and we've validated that everything that we want to instantiate is there. So let's go ahead and run a Terraform apply. Now, I am a professional, so don't do this at home. There is something that we like to call Terraform YOLO, which is this, or actually I have to go into the right file. We call this Terraform YOLO because you're not really supposed to do this. This is really just reserved for professionals, demos, and trialing things out. This auto-approve flag will not ask you if you are sure that you actually want to go ahead and run this code. It does come in handy if you've automated pipeline or anything like that. So what just happened is we're actually going ahead and creating these GitHub repositories. I literally just got an email saying a new public key was added to onlydol/test provider, which is my repository that I'm going to be using for Flux and all of that configuration. So we do have quite a few things to install here. So that's what's happening here in the background. If we wanted to take a look and see what's actually going on, we could open up a new shell, hello cow, and see that, okay, so we have our Flux system namespace that we have created. In the background, I had to refresh my cluster, so you'll notice some of this age is a little bit different than you'd seen before. So let's go ahead and take a look at, let's jump into Flux system. KubeNS and kubectx are a wonderful project. If you haven't checked those out, that'll basically manage your Kubernetes configuration and or namespaces. If I were to run KubeNS, it's going to go ahead and list all of the different namespaces that I have available to me, and then highlight which one I'm using, which is quite helpful. So let's go ahead and run a kube control, get pods. Fantastic. That's what we want to see. Let's jump back to our first shell and see, oh, okay, we're already done. We're good to go. So what we can now see is that we have all of this Flux infrastructure up, running, and working as it's supposed to. I believe we can do watch Flux. Let's see here. I have it here somewhere. Fantastic. I'm not sure if you're like me. Rather than research or type the right thing, I like to just see if I can find it in my shell history. So let's go ahead and see. Okay, great. So this is exactly as we want to see it. Flux system is up, running, working, and then we can see it's ready, which is where you see the true, and my screen is a little bit compacted, so if I were to shrink this down a bit, it would look a little bit better. You just wouldn't be able to read it. That's ready. It's applied the revision, and we're good to go. I'm actually going to go ahead and leave this up in this shell. I'm going to, so right now we're in this directory on my machine inside of our layered governance repository. We're actually going to venture away from this repository and go to, so it's up to projects. I'm going to use the GitHub command line, and we're going to clone that repository that we just created. Great. So let's go in there, test provider, and we can see this is everything I need to start working with Flux. I'm going to go into my staging cluster folder. So again, here is this. And then inside of Flux system, you would actually see, let me go ahead and show you what's inside there. Don't want anything to be hidden from you. So we can see that we have our components and sync and customization files. If you wanted to take a look at any of those, you can see that like in customization, not too much here, but just know that all of those items are configured and good to go. Let's close out of that. I believe that we're in the right folder. Great. Okay, so earlier I showed you those two files that we want to create. First one is going to be a source, and I actually want to be in the right place. First one's going to be source. So that one project pod info at this GitHub repository is what we want to create as our source. Then we want to go ahead and create that customization. So now we should see in our staging cluster that we have pod info customization and pod info source. Fantastic. Now again, we have not deployed these yet. The reason is because I've not committed them yet. Flux is running, it's working, it's ready to go. So as soon as I want to add these items, just go ahead and get this. Actually, I think I had a, again, like to use what I have had already. Never mind. Let's go ahead. We already added that. Let's just do this and add our initial Flux example, and then go ahead and push that. Fantastic. So that's pushed. I'm just gonna chill here for a second and wait for Flux to work its magic. Flux is going to check in. You can set all of these numbers for exactly the way in which you would want, whether that be 30 seconds, a minute, 5 minutes. Flux does come with quite a few defaults already ready and good to go. I believe we set this for, we set one for 5 minutes, and we set one for 30 seconds. So we can see there's a reconciliation in progress that's happening. There's our pod info, and boom, there it is. It's already done. We did it. How awesome is that? Let's go ahead and take a look at what we've created. So let's go into, I believe this is going to be in our default namespace, if I'm not mistaken. Let's go ahead and check our pods. Fantastic. Let's go ahead and actually watch that, because I do want to see that come up. Cool. So we're waiting for that to get to a ready state. Probably take just a few more seconds, and then we will have successfully installed Flux in our Kubernetes cluster using Terraform. There it is. We have it. We're good to go. Awesome. So there is demo number 1. Demo number 2 we have for you is policy as code. So you'll remember, I'll actually get rid of my terminal for just a moment. So you remember with Terraform, again, we have required providers. We've pinned these providers. In here, I've worked a little bit with Kubernetes Alpha and that provider. I did run into a couple issues. Again, it is alpha and still being developed on. There's a bit of a race condition when you're going about setting up these policies for Gatekeeper. Gatekeeper, installing that just out of the box is quite easy. This is all that you need to get started with Gatekeeper. This is it. You don't need to set anything too specific unless you want to, or unless it applies to your workflow. But it's quite easy to install and start working with right out of the get-go. We have to set up the Helm provider because we just have to pass it some default Kubernetes configuration information. Here it's just the config path. I'm just using this locally. Kubernetes Alpha, it's the same thing. I believe that we're just going to go ahead and actually skip that today. We could YAML, so for manifests with the Kubernetes Alpha provider, you do have to have it in HCL format. There are a few different ways you can do that. Some tools that will actually move YAML format over to HCL. Transpile is, I believe, the correct term for that. Or we can just use these functions. We can load up the file, path to the module, policies, all must have owner, constraint, and template. For now, I'm just going to go ahead and comment these out because I want to show this concept to you directly. And I do have these policies here, these constraints, and these templates. The constraint is actually the rule inside of Open Policy Agent and Gatekeeper for what we want to do. So here we can see this is the rule that's actually going to be evaluated, and then the template is going to be the Rego itself. So we can see here, and then just passed in here is, make this a little bit better, a little bit easier to read. Shrink this down just a bit. We can see we have case required labels, and then this is the Rego code that's actually going and checking to make sure that everything is as we expect it to be. All right, so let's take a look at this. Let's go ahead and run a Terraform plan and make sure that Gatekeeper comes up as the Helm chart that's going to be installed. And fantastic. This is exactly as we want. Let's go ahead and run a Terraform YOLO yet again and get Gatekeeper installed on our Kubernetes cluster. Wow, it's so fast and so wonderful. That's exactly what we want to see. Love it when deploys are that easy. And when they're not on Fridays, of course. So we have installed Gatekeeper onto our cluster. Now we do need to, that's great. We need to be able to utilize this though. All right, so we're going to go ahead and apply the template and then the constraint. So let's go ahead and apply our template. And then we'll go ahead and apply our constraint. Fantastic. So now that we have that, we can go ahead and take a look at, we can see our different CRDs here. We can see when they've been created, and that's exactly what we want to see. If we go ahead and, actually, let me shrink this down and show you what's going on here. This is a namespace that I've created, and it won't work. We've defined a owner tag right here, but this won't work because it doesn't have a username .HashiCorp inside of it. Whereas we have this one, which I'm using my username and .HashiCorp. This is going to work. This is exactly what we want across our cluster. So if we go ahead and we try to apply our sample failure, it's not going to work. It's going to give us this error message, and we can see that Gatekeeper is working as it's supposed to. If we go ahead and we do the sample success, we're going to go ahead and see that we've actually created that namespace, and we can actually switch into that namespace, which is called layered compliance. Boom. Just like that, we've switched into it, and we're ready to get more compliant and spin up some more code. So that concludes this session. Thank you so much for stopping by. I'd be more than happy to answer any questions that you might have. And again, I'm going to share out these slides and code, and really just if there are any other questions or things I can help you with, sincerely would be more than happy to help you out on that front. Until then, have a fantastic day, and stick around if you have any more questions. Talk to you.